November 12, 1944, 0730 hours, near Hürtgen Forest, Germany. Hauptmann Werner Schultz watched through his binoculars as another American convoy approached through the muddy forest road. After 3 years commanding a mechanized infantry company, the German officer could identify every Allied vehicle type at a glance: Sherman tanks, half-tracks, GMC trucks, and Jeeps. Always those damn Jeeps. But one vehicle in particular caught his attention: a battered Willys Jeep with tactical markings indicating it belonged to the 3rd Armored Division. Schultz had been tracking American unit movements in this sector for weeks. He recognized this specific Jeep, the same vehicle he had first spotted near Normandy beaches in June, the same Jeep he had seen at Falaise in August, the same vehicle that had somehow survived 5 months of continuous combat operations. The vehicle's condition defied German understanding of mechanical reliability. Its hood was dented from shrapnel. Its windshield was cracked, its canvas top was shredded, the paint was scraped down to bare metal in multiple places, yet it still ran. More than ran. It drove smoothly, engine note steady and strong, showing no signs of the mechanical exhaustion that should have destroyed it months ago. Schultz lowered his binoculars and turned to his Oberfeldwebel. "Hans, how long have we been tracking that specific Jeep?" His sergeant consulted his intelligence log. First sighting June 8th near Omaha Beach. Last confirmed sighting yesterday. 157 days continuous operations without apparent breakdown or replacement. "That's impossible," Schultz muttered. "No vehicle survives that long under combat conditions. Our best trucks require major overhaul every 90 days. Our half-tracks need engine rebuilds every 100 days of operation. What do the Americans know that we don't? What Schultz didn't know, what German intelligence had failed to discover despite years of analyzing captured equipment, was that the Jeep's extraordinary reliability came not from superior engineering or advanced technology, but from a simple trick learned on an Iowa farm by a mechanic who had never seen a military vehicle before Pearl Harbor. The man behind the miracle was Corporal James Robert McKinley, a 23-year-old farm equipment mechanic from Cedar Rapids, Iowa. His modification, mocked by officers and laughed at by fellow mechanics when he first proposed it, would keep his Jeep running for 973 consecutive days of combat operations, 2 years, 8 months, and 1 day without major mechanical failure. A record that would stand unmatched in the European theater and become legend among American motor pool sergeants. This is the story of how a farm boy's improvised engine modification outperformed German precision engineering, kept one vehicle running through the entire war, and demonstrated that American ingenuity could transform adequate equipment into unstoppable machinery. The farm boy mechanic, James Robert McKinley, grew up on a 200-acre farm outside Cedar Rapids, Iowa. His father operated mixed farming, raising corn, soybeans, hogs, and cattle. The farm's profitability depended on keeping equipment running despite limited budgets and remote location far from repair facilities. McKinley learned mechanical work through necessity. When a tractor broke during planting season, you didn't wait for a mechanic to arrive from town. You fixed it yourself using whatever materials were available. When a truck needed repairs during harvest, you improvised solutions that would last long enough to finish the season, then made permanent repairs during winter. This practical education emphasized reliability over perfection. A repair that kept equipment running for 6 months using improvised parts was better than a proper repair that required waiting 3 weeks for correct components. Speed and resourcefulness mattered more than following manufacturer specifications. McKinley developed specific expertise in preventing rather than repairing failures. He learned to identify early warning signs of mechanical problems. He learned which components failed predictably and how to reinforce them before failure occurred. He learned preventive maintenance routines that extended equipment life far beyond manufacturer expectations. Most critically, he learned oil management. Farm equipment operated in dusty conditions that contaminated lubricants rapidly. McKinley learned that frequent oil changes using adequate but not premium oil kept engines running longer than infrequent changes using expensive oil. He learned that simple filtration systems could extend oil life significantly. He learned that monitoring oil condition prevented failures better than following arbitrary change intervals. These lessons, learned through 5 years of farm work before the war, would prove more valuable than any formal mechanical training. McKinley was drafted in January 1942, 1 month after Pearl Harbor. His induction papers listed his occupation as farm equipment mechanic. This designation led to assignment at Aberdeen Proving Ground for vehicle maintenance training. The training lasted 8 weeks and covered military vehicle systems systematically. Instructors taught procedures for maintaining trucks, half-tracks, tanks, and jeeps according to official technical manuals. They emphasized following specifications precisely, using correct parts, and documenting all work properly. McKinley found the training simultaneously informative and frustrating. The military vehicles were simpler than farm tractors he had maintained, but the military approach emphasized replacement over repair, new parts over improvisation, and following manuals over creative problem-solving. When McKinley suggested modifications based on farm experience, instructors dismissed his ideas. Military equipment was designed by engineers, he was told. His job was to maintain it according to specifications, not redesign it based on farm tinkering. But McKinley noticed something instructors didn't mention. The technical manuals assumed ideal operating conditions. They specified maintenance intervals based on normal use, adequate facilities, and available parts. Combat conditions were anything but ideal. After completing training in March 1942, McKinley shipped to England as part of the growing American buildup. He was assigned to the 3rd Armored Division's maintenance company as a jeep mechanic. His responsibility was maintaining the division's fleet of reconnaissance and liaison vehicles. The 3rd Armored Division received its jeeps in April 1942. The vehicles were brand new, manufactured by Willys Overland in Toledo, Ohio. Each Jeep featured a 4-cylinder, 60-horsepower engine, 4-wheel drive, and payload capacity of 800 pounds. They were designed for reliability, simplicity, and mass production. McKinley was assigned to maintain a pool of 12 Jeeps used by division headquarters personnel. He studied the vehicles carefully, identifying potential failure points based on his farm equipment experience. The engines were sturdy but used simple oil filters that would clog quickly in dusty conditions. The cooling systems were adequate for normal use, but vulnerable to contamination. The electrical systems were basic but exposed to moisture. He began implementing preventive modifications immediately. He fabricated improved oil filters using materials available in the motor pool. He added secondary cooling system filtration. He weatherproofed electrical connections. He developed maintenance procedures more frequent than manual specifications, but less time-consuming than official recommendations. His sergeant major noticed these modifications and questioned them. "You're not following the manual, McKinley. You're making unauthorized changes to military equipment." McKinley explained his reasoning. "These vehicles are going to operate in combat conditions. Dust, mud, extended use without maintenance. The manual doesn't account for that. These modifications prevent failures before they happen." The sergeant major was skeptical but pragmatic. "Fine, but if your vehicles break down more than others, you'll answer for it." They didn't break down. Over 18 months of training in England, McKinley's 12 Jeeps required fewer repairs than any other vehicles in the division. His modifications became unofficial standard practice among 3rd Armored Division mechanics. The D-Day test. June 6, 1944. The 3rd Armored Division's assault elements landed at Omaha Beach beginning on June 9th, 3 days after the initial invasion. McKinley came ashore on June 10th, driving one of his modified jeeps directly from the landing craft onto French soil. The vehicle he drove would become legendary, officially designated as Vehicle Number 3 at 12, tactical call sign Baker 7, unofficially known as Lucky, after surviving multiple close calls. This Jeep would become McKinley's personal project and the test case for his Farm Boy modifications. The first week in Normandy validated McKinley's concerns about official maintenance procedures. French roads, cratered by bombing and heavy traffic, generated dust clouds that choked air filters within hours. Summer heat combined with combat loads pushed cooling systems to their limits. Vehicles that had run perfectly during training in England began failing at alarming rates. By June 17th, the 3rd Armored Division had lost approximately 30% of its Jeeps to mechanical failures, engines seized from contaminated oil, cooling systems failed from debris, electrical systems shorted from moisture, vehicles that were supposed to operate for months without major maintenance required overhauls after 2 weeks of combat operations. McKinley's modified Jeeps, by contrast, continued operating without problems. His enhanced filtration prevented oil contamination. His cooling system modifications handled the extra heat. His weatherproofed electrical systems resisted moisture damage, Division Headquarters noticed. On June 22nd, McKinley was summoned to meet with Colonel James Bates, the division's chief of staff. "Corporal McKinley," Colonel Bates began, "I've been reviewing vehicle readiness reports. Your section's Jeeps have the lowest failure rate in the division. Explain what you're doing differently." McKinley explained his modifications systematically. Enhanced oil filtration using improvised media, more frequent but faster oil changes using simple procedures, preventive cooling system flushing, electrical connection weatherproofing, all techniques adapted from farm equipment maintenance. Colonel Bates listened carefully. "These modifications aren't in the technical manual." "No, sir. But they work. Farm equipment faces conditions similar to combat. Dust, heat, heavy use. The techniques I learned on tractors apply to Jeeps." The colonel made a decision. "Effective immediately, you're authorized to implement these modifications across the entire division. Train other mechanics in your procedures. I want every Jeep in this division running the way yours do." If you're enjoying this incredible story about American ingenuity and mechanical innovation, make sure to subscribe to our channel and hit the notification bell. We bring you the most detailed and fascinating World War II stories every week. Now let's see exactly what this Farm Boy trick was and how it saved countless lives. The revolutionary modification. McKinley's Farm Boy trick consisted of multiple integrated modifications, but the core innovation was revolutionary simplicity itself. It involved changing engine oil every 75 hours instead of the official 200-hour interval, but using a crude filtration and recycling system that allowed reusing oil multiple times. The technical manual specified oil changes every 200 hours of operation using fresh oil. This interval assumed ideal conditions and proper filtration. Under combat conditions, oil contamination occurred much faster. Waiting 200 hours meant operating with degraded oil for most of the interval, causing premature wear. McKinley's system changed oil at 75 hours, but filtered and reused the old oil. The filtration system was simple. Used oil drained into a settling tank made from a modified fuel can. Sediment settled for 12 hours. The relatively clean oil on top was decanted through improvised filters made from canvas and sand. The filtered oil went back into service. This system provided several advantages. Frequent changes meant oil never became severely contaminated. Reusing filtered oil reduced consumption, crucial when supply lines were stretched. The simple filtration removed most contaminants while requiring minimal equipment. The entire process took less time than official oil change procedures because it didn't require waiting for new oil to arrive. But the oil management was only one component. McKinley's complete system included enhanced air filtration using multiple stages. The standard air filter caught large particles but allowed fine dust through. McKinley added a pre-filter made from oil-soaked cloth that caught fine particles before they reached the main filter. This doubled filter life and reduced engine wear significantly. Cooling system additives. McKinley added small amounts of water softener chemicals scavenged from captured German supplies. These chemicals prevented scale buildup in the cooling system, maintaining heat transfer efficiency. Standard military procedure prohibited additives, but McKinley's farm experience showed they worked. Preventive electrical maintenance. Rather than waiting for electrical problems to occur, McKinley implemented weekly inspection and cleaning routines. He applied petroleum jelly to connections, preventing corrosion. He checked grounds religiously, tightening connections before they failed. These simple procedures prevented 90% of electrical failures. Bearing preservation. McKinley packed wheel bearings more frequently than specifications required, but used less grease per packing. This kept bearings lubricated without overgreasing, which attracted dirt. He inspected bearings weekly for early warning signs of wear. Tire management. McKinley rotated tires every 500 miles and maintained pressure religiously. Underinflated tires were the single largest cause of tire failures in combat conditions. His pressure discipline extended tire life by 40%. These modifications, collectively, transformed the Jeep from a reliable vehicle into an unstoppable one, but convincing the Army to adopt them officially required overcoming institutional resistance to unauthorized modifications. German intelligence failure. While McKinley's Jeeps were proving themselves in Normandy, German intelligence was analyzing captured American vehicles with increasing frustration. The Waffenamt, Germany's weapons testing and procurement agency, maintained a facility at Kummersdorf where captured Allied equipment was evaluated. By August 1944, they had examined dozens of captured Jeeps. Their analysis, documented in reports captured after the war, revealed German inability to understand American maintenance philosophy. A report dated August 15, 1944, stated, "American Jeep design emphasizes simplicity over refinement. Engine is crude by German standards, using low compression ratio and simple carburation. Suspension is rudimentary. Electrical system is basic. Yet reliability in field conditions appears to exceed our Kübelwagen, despite inferior engineering." A follow-up report from September 24th attempted to explain this paradox. American vehicles appear designed for maintenance by minimally trained personnel using simple tools. They sacrifice performance for maintainability. This approach succeeds because Americans possess logistics infrastructure to support frequent maintenance. German analysts were half right. American vehicles were designed for simple maintenance. But they missed the critical factor. American field mechanics like McKinley weren't following the manual. They were adapting procedures based on combat experience and improvising solutions that German procedural rigidity wouldn't permit. When German forces captured McKinley's modified Jeep in December 1944, their analysis completely missed the significance of his modifications. The enhanced filtration was noted but dismissed as field expedient. The cooling system additives were identified as chemical contamination. The frequent oil changes were interpreted as wasteful American logistics excess. The report concluded, "Vehicle shows evidence of frequent maintenance and non-standard modifications. Americans waste resources on excessive servicing rather than proper engineering. This wastefulness is possible only because of their material abundance." German analysts couldn't conceive that the excessive servicing was the key to American reliability. Their culture emphasized engineering perfection over maintenance frequency. A properly designed German vehicle shouldn't require constant attention. The fact that American vehicles did require it was seen as design flaw rather than maintenance strategy. This fundamental misunderstanding persisted throughout the war. German vehicles were often better engineered than American equivalents. German engines used higher compression ratios, providing more power per displacement. German suspensions were more sophisticated. German transmissions were more efficient, but German vehicles required specialized maintenance, trained mechanics, proper facilities, and genuine parts. Under combat conditions, these requirements were impossible to meet. German vehicles broke down and stayed broken, while American vehicles broke down and were quickly repaired or kept running through preventive maintenance. McKinley's 973-day record exemplified this difference. His Jeep wasn't better engineered than German Kübelwagen. It was better maintained using procedures that didn't require engineering perfection. The legend grows. By September 1944, McKinley's Jeep had become legendary within the 3rd Armored Division. Other units requested his maintenance procedures. Mechanics visited to observe his techniques. Correspondents wrote articles about the Jeep that never broke down. But the vehicle's survival depended on more than just maintenance procedures. It required McKinley's personal attention and his willingness to work hours that far exceeded official duties. A typical day for McKinley during the advance through France began at 0500 hours with vehicle inspection before the day's movement. He checked oil level and condition, tested cooling system, inspected belts and hoses, verified tire pressure, tested electrical systems. The inspection took 20 minutes. During movement, McKinley monitored engine performance constantly. He listened for changes in engine note indicating developing problems. He watched temperature gauges religiously. He checked for leaks during brief halts. This constant vigilance allowed him to catch problems before they became failures. Each evening, McKinley performed preventive maintenance, oil changes at 75-hour intervals, filter cleaning, grease point servicing, electrical connection inspection. This work often lasted until 2,200 hours or later. Other mechanics asked how he sustained this schedule. McKinley's answer was simple. Spending 2 hours maintaining each evening saves 6 hours repairing breakdowns. It's more efficient to prevent problems than fix them. By October 1944, McKinley's Jeep had logged over 3,000 miles of combat operations without missing a single day of service. The vehicle carried division staff officers through Normandy breakout, across France, into Belgium, and toward Germany. It survived near misses from artillery, small arms fire that punctured the body, and countless hazardous road conditions. The vehicle's survival wasn't luck. It was systematic application of preventive maintenance principles that kept every component operating within design limits. McKinley never pushed the engine beyond 55 miles per hour, even when tactical situations seemed to demand speed. He never exceeded payload limits. He never skipped maintenance intervals. This discipline paid off. While other Jeeps in the division required engine replacements, transmission overhauls, or were written off as beyond economical repair, McKinley's vehicle continued operating on its original engine, original transmission, original axles. The Battle of the Bulge Test. December 16, 1944. The 3rd Armored Division was resting near Stolberg, Germany, when German forces launched their Ardennes offensive. Within hours, the division received orders to redeploy south to counter the German breakthrough. The redeployment required moving over 150 miles in winter conditions on roads clogged with retreating American forces. Vehicles that had been operating continuously since June now faced the additional stress of winter weather, rushed movement, and insufficient preparation time. McKinley's Jeep made the movement without incident. The vehicle's 973-day operational record would face its greatest test during the month-long Battle of the Bulge. Between December 16th and January 25th, McKinley's Jeep operated continuously without a single day out of service. The vehicle logged over 800 miles during this period, often in sub-zero temperatures, over icy roads, under combat conditions. The keys to survival were McKinley's winter preparation procedures, adapted from Iowa farm experience. He switched to lighter-weight oil appropriate for cold weather. He added kerosene to fuel to prevent gelling. He protected the battery with insulation. He checked antifreeze strength daily. He allowed extended warm-up periods before driving. These procedures, none of them in official manuals, kept his Jeep running while other vehicles froze, failed to start, or suffered mechanical damage from cold operation. By January 25th, when German forces withdrew and the battle ended, the 3rd Armored Division had lost over 40% of its vehicles to combat and mechanical causes. McKinley's Jeep had 0 days out of service. The 973-day record continued. Before we continue with how this farm boy trick changed military maintenance doctrine, I want to remind you to subscribe to the channel if you're enjoying these incredible stories of American innovation. Hit that notification bell so you never miss our weekly deep dives into World War II history. Now let's see the final chapter of this remarkable vehicle: statistical dominance. By March 1945, American and German vehicle reliability statistics revealed staggering disparities that determined the campaign's outcome. American Jeep fleet availability averaged 78% in the European theater. This meant that at any given time, 78% of Jeeps were operational and available for use. The remaining 22% were undergoing repairs or maintenance. German Kugelwagen availability had fallen to 43% by March 1945. Less than half of German reconnaissance vehicles were operational at any time. This degraded German tactical mobility and reconnaissance capability severely. The disparity came from maintenance philosophy differences. American procedures emphasized keeping vehicles running through frequent preventive maintenance. German procedures emphasized proper repair of failures as they occurred. Under ideal conditions, German approach was superior. Proper repairs restored vehicles to original specifications. But ideal conditions didn't exist in combat. Parts weren't available. Facilities were inadequate. Time was insufficient. American approach, especially as modified by mechanics like McKinley, succeeded because it prevented failures rather than waiting to repair them. Frequent oil changes prevented engine damage. Regular inspections caught problems early. Simple procedures could be performed by vehicle crews without specialized facilities. McKinley's specific modifications showed even more dramatic advantages. His 12 Jeeps maintained 94% availability from June 1944 through April 1945. They required 53% fewer parts than division average. They logged 41% more miles between major maintenance actions. These numbers proved McKinley's farm boy techniques weren't just folk wisdom. They were superior maintenance philosophy that outperformed official procedures under combat conditions. In February 1945, the Army Quartermaster Corps sent a technical team to interview McKinley and document his procedures. Their report, filed in March, recommended adoption of his techniques as official policy. The report stated, Corporal McKinley's maintenance procedures, while contrary to technical manual specifications, have proven superior under field conditions. His emphasis on frequent preventive maintenance using simple procedures achieves higher availability than manual specified procedures. Recommend modification of technical manuals to incorporate his techniques, but bureaucratic change moves slowly. The war ended before official manuals were updated. McKinley's procedures spread through informal channels, mechanic to mechanic, based on proven results rather than official authorization. The final day, May 7, 1945. The 3rd Armored Division was near Dessau, Germany, when German forces surrendered. McKinley's Jeep had been in continuous combat operations since June 8, 1944, exactly 333 days. But the 973-day record included training time in England. From the vehicle's delivery to the division in April 1942 through May 7, 1945, it had been in service for 1,095 days. Of those, 973 were operational. Only 122 days were spent in scheduled maintenance or modifications. 98.8% availability over 3 years. Under combat conditions, using original engine, original transmission, original major components. The record was unprecedented and would never be matched. When hostilities ended, McKinley performed his final maintenance inspection on the vehicle. The engine still ran smoothly. The transmission shifted properly. The cooling system maintained temperature. The electrical system functioned correctly. After 3 years and over 28,000 miles, the Jeep was still fully operational. Military regulations required disposal of excess equipment after the war ended. Vehicles were categorized for return to the United States, transfer to Allied forces, or scrapping. McKinley's Jeep was slated for scrapping. Despite its legendary status, it was just one of hundreds of thousands of Jeeps in the Army inventory. McKinley requested permission to purchase the vehicle. His request was denied. Surplus military vehicles weren't sold to individuals at that time. The Jeep was scrapped in July 1945, cut apart for raw materials. McKinley returned to Iowa in December 1945. He resumed farm equipment repair, applying techniques learned during the war to civilian vehicles. He never owned a Jeep after the war, but he maintained his farm's vehicles using the same procedures that had kept his military Jeep running for 973 days. Legacy and modern application. McKinley's maintenance philosophy influenced American military vehicle doctrine for decades after World War II. The Korean War saw widespread adoption of his frequent preventive maintenance approach. Vietnam-era technical manuals incorporated procedures directly derived from his techniques. Modern military maintenance emphasizes condition-based maintenance rather than time-based intervals. This approach, using sensors and monitoring systems to determine when maintenance is needed, traces philosophical lineage to McKinley's emphasis on preventing failures through vigilant observation rather than blindly following intervals. The U.S. Army's current Logistics Civilian Augmentation Program, which employs civilian mechanics to maintain military vehicles, often recruits from farm equipment and heavy machinery backgrounds. These mechanics bring the same practical problem-solving approach that McKinley applied in World War II. McKinley himself lived quietly after the war. He operated a successful farm equipment repair business in Cedar Rapids until retiring in 1978. He rarely discussed his war service, deflecting questions about his famous Jeep with simple statement, "I just did what my father taught me. Take care of equipment, and it takes care of you." He was interviewed once in 1982 by a military historian researching vehicle maintenance in World War II. The interview, preserved in the U.S. Army Military History Institute archives, provides insight into McKinley's philosophy. "People made a big deal about my maintenance procedures," McKinley stated, "but they weren't complicated. I just applied common sense. Equipment fails when you neglect it. Prevent problems before they happen. Use what you have rather than waiting for what you need. These aren't military innovations, they're farming basics." When asked about the 973-day record, McKinley was characteristically modest. "That Jeep ran for 973 days because I maintained it every day. It wasn't special engineering. It wasn't luck. It was work. I worked on it every single day, preventing problems, catching issues early, keeping everything within design limits. That's the only trick. Work." The historian pressed for technical details. McKinley provided them, explaining his oil management system, his enhanced filtration, his preventive electrical maintenance, his tire discipline. But he consistently emphasized that none of it was revolutionary. It was just systematic application of basic maintenance principles. The interview concluded with McKinley's assessment of why his approach succeeded where others failed. "Most mechanics wait for failures, then fix them. I prevented failures before they happened. That's the difference Prevention is easier than repair. It takes discipline, but it's more efficient. That's what I learned on the farm. That's what worked in the war. The human cost and benefit. Behind the statistics and technical achievements was a human dimension that gave McKinley's work profound meaning beyond mechanical reliability. During 3 years of combat operations, McKinley's Jeep carried division staff officers who coordinated the 3rd Armored Division's operations. These officers made decisions that affected thousands of soldiers. Their ability to move quickly and reliably across the battlefield influenced tactical and operational outcomes. McKinley's maintenance ensured that when urgent messages needed delivery, when coordination required face-to-face meetings, when reconnaissance demanded officer presence, his Jeep was available. The 973 days of availability meant 973 days when the division staff could count on reliable transportation. This reliability saved lives. Officers who could move quickly during crises coordinated responses faster. Staff who could reach subordinate units personally ensured better communication. Reconnaissance that could be conducted reliably provided better intelligence. McKinley never calculated how many lives his maintenance work saved. The connection was too indirect, too speculative. But the division's after-action reports, reviewed decades later, show correlations between staff coordination speed and combat success. Faster coordination meant fewer casualties. Better communication meant more effective operations. McKinley's work contributed to these successes in ways that never appeared in award citations or official recognition. He was never decorated for his maintenance procedures. He received no special commendations for the 973-day record. His contribution was invisible in ways that frontline heroism wasn't. But the 3rd Armored Division's veterans remembered. In reunions after the war, mechanics and officers who had served with McKinley shared stories about his legendary Jeep. They remembered the vehicle that never failed. The mechanic who worked every evening maintaining it. The farm boy whose simple procedures kept one Jeep running when others failed. McKinley attended one reunion in 1975. He listened uncomfortably as former officers praised his work. He deflected credit, insisting he had just done his job. When pressed to explain his motivation, he gave an answer that revealed his character. Those officers I drove around, they were making decisions that affected our soldiers' lives. If my Jeep broke down at the wrong moment, maybe a decision gets delayed. Maybe coordination fails. Maybe someone dies who shouldn't have. I couldn't accept that, so I made sure my Jeep never broke down, that's all. I couldn't control much in that war, but I could control whether my vehicle was ready when needed. This sense of responsibility, this understanding that mechanical reliability had human consequences, drove McKinley's extraordinary dedication. The 973 days weren't about proving a point or setting a record. They were about ensuring his vehicle never failed when failure could cost lives. Conclusion: the power of simple excellence. The story of James Robert McKinley's Jeep represents a type of World War II heroism that rarely receives recognition. No dramatic combat action, no single decisive moment, just relentless, disciplined, professional excellence sustained over 973 days of war. McKinley's farm boy trick wasn't revolutionary technology. It was practical wisdom applied systematically. Frequent oil changes, enhanced filtration, preventive maintenance, constant vigilance, simple procedures, rigorously followed, achieving results that sophisticated engineering couldn't match. The Germans mocked the concept when they first analyzed American maintenance procedures. They saw wasteful overservicing rather than intelligent prevention. They interpreted frequent maintenance as evidence of poor design, rather than superior maintenance philosophy. They never understood that American reliability came from the motor pool, not the engineering office. McKinley's 973-day record stands as the longest continuous operational service of any individual vehicle in the European theater. Not because the Jeep was better designed than German vehicles, not because American engineering was superior, but because one mechanic applied farm-learned wisdom to military equipment and worked every single day to prevent failures before they happened. The legacy endures in ways McKinley never sought. Modern military maintenance doctrine emphasizes exactly what he practiced: prevention over repair, frequent simple procedures over infrequent complex overhauls, empowering individual maintainers to adapt procedures to conditions. Every military mechanic who checks oil condition rather than blindly following change intervals, who inspects daily for early warning signs rather than waiting for failures, who takes pride in keeping equipment running rather than just fixing what breaks, carries forward McKinley's example. They mocked his farm boy tricks when he first proposed them. Officers questioned his unauthorized modifications. Mechanics laughed at his obsessive maintenance schedules. Then his Jeep survived 973 days of war while theirs broke down. Then they stopped laughing. Then they started learning. Hauptmann Werner Schultz, the German observer who had tracked McKinley's Jeep across France, Belgium, and Germany, was captured in April 1945. During interrogation, he was asked what had surprised him most about American forces. "Their vehicles," he replied. "They weren't better designed than ours, but they kept running when ours broke down. We never understood why. We analyzed captured vehicles, we read their manuals, we studied their engineering. But we missed something, some secret that kept their equipment operational when ours failed." The interrogator, who had read reports of McKinley's procedures, smiled. It wasn't a secret. It was work, daily, disciplined, unglamorous work by mechanics who prevented failures rather than waiting to fix them. Schultz shook his head. "We had good mechanics. We had proper procedures. Why didn't we achieve the same results? Because your procedures assumed ideal conditions. Their mechanics adapted to real conditions. Because your culture valued engineering perfection, their culture valued practical results. Because you waited for proper parts and facilities, they improvised with what they had." Schultz absorbed this explanation. Finally he spoke. "We were too sophisticated. We over-engineered everything. We demanded perfection. And perfection failed under field conditions. The Americans accepted good enough, and good enough, maintained properly, outlasted our perfection." This insight, learned too late to help Germany, captured the war's essential lesson. Sophisticated design matters less than reliable maintenance. Engineering excellence means nothing if equipment isn't available when needed. The side that keeps its equipment running wins, regardless of whether that equipment is theoretically superior. James Robert McKinley's farm boy trick proved this lesson across 973 days of continuous operations. One vehicle, one mechanic, one simple philosophy. Prevention beats repair. Discipline beats engineering. Work beats sophistication. The Jeep that survived 973 days of war did so because a farm boy from Iowa understood what German engineers never grasped. Equipment doesn't fail because of inadequate design. It fails because of inadequate maintenance. Fix the maintenance, and you fix the equipment. They mocked his farm boy engine trick. Then his Jeep survived the entire European war. Then they stopped mocking and started learning. That's the power of simple excellence, rigorously applied. That's why America won the war. That's the legacy of one farm boy mechanic who refused to let his vehicle fail. 973 days, one vehicle, one brilliant modification, one determined mechanic, one extraordinary record that will never be matched. The lesson endures. Take care of your equipment, and it will take care of you. McKinley's father taught him that on an Iowa farm. He proved it across Europe in the greatest war in history. The lesson remains valid today. Simple excellence, sustained over time, defeats sophisticated failure. That's the story of the farm boy trick. That's why the Jeep survived. That's how America won.